Hello. So this is Haskell Khan. Haskell Khan. Haskell Khan. It sounds like a really great villain from Star Trek, the USS Nixos Discovery. Anyway, I was doing a little bit of more. It's not that I've stopped doing Nixos. I'm actually working on a. I'm thinking about doing like a deep dive into the module system, and that has already been covered on NixDev by Great in Finicel. So yeah, I'd like to do like a deep dive into it. But I've been also doing this super interesting Khan Academy and using Haskell to solve it. Um, yeah, my wife works as an assistant in a school, and she helps someone with learning disabilities or difficulties. Not sure what's the correct term. In to learn math, and this kind of reminds me. And I also teach. I teach guitar, so I know that's my experience. That a lot of the like just like a week ago someone was saying to me, what's the point of math, why do they have to learn it? And even the teacher sometimes says that to them, like, you won't need this in life. As in, that's gonna help really. How are you going to teach someone and you tell them you don't really need this, but you have to do it? Okay, no, I don't want to sidetrack now and talk about this because this will turn into a 24-day stream. So I'll just go get back to Haskell Khan Academy, and I think it'd be great if kids would do, functional programming together with math, because a lot of the stuff what they do is like tricks. Like I've been looking at the equations, and do I have to put more sound like this? Yeah, I'll try like this. I've been looking at the equations. Let's try like this. No, that's too much. I've been looking at the equations, and like in the school they learn, well, if it's plus on this side, it's minus on that side. But what's the understanding? So a lot of the stuff what they learn is basically some kind of operational semantics, right? Like what, or some tricks. It's horrible. They have to learn tricks. Like, why do I need to learn tricks? It's not like a skateboard trick. It's anyway. So a cool thing is like, where is the my progress? Evaluating expressions with one variable. Great. I cannot open it. Why cannot? Course says algebraic resume. Maybe here resume algebra basics. Unit 1 foundations. Adding numbers, linear equations, algebraic expressions. What is a variable? Evaluating expressions with one variable, a quiz. Let's try a quiz. So the one cool thing is like evaluate 2d plus 3 when d is 8. Like when we learn Haskell and you know and then we do like the lambda calculus. This is kind of too white. Wait. Let me just yeah, I'd like change a lot. Wait, oh, what's this? Sumac Knight. Maybe I'll try this Sumac Knight. Utterly ignored. This is kind of nice. Why not? Let's try this. Is it too white? Maybe. I don't know. So look, 2d plus 3 when d is 8. So, and then you have to do like all this shifting around, like 2d plus 3 when d is 8. How do you solve this? Okay, like 2d plus 3 when d is 8. 8, d is 8. 2 times d, 2 times 8 is 16 plus 3 is 19. But like you can use, I think this is a, you can use the simplest lambda expressions. Let's say, so what like the x times x is, well, we could do like d, right? D. So what's the d when d is 8? But we have to input the d. So look, I thought this, look, 2d plus 3. So d and 2d plus 3 when d is 8. And we put 8 outside. So you look at this, we have a lambda expression, and then, no, it doesn't work. What did I do wrong? 2d, what's wrong? Let's try a more simple one. Let's build it. Come on. So lambda d, and if, well, let's give it an 8. It works. Okay, that's a simple identity, right? The d, it could be an x. It's not the point. Like in this way, you can show them, because 8, but 8 just by itself is 8. So what's the difference? Well, this is a function application. This is just yeah, I'm not sure the right name. We just like inputting like a value, and then the interpreter gives us back the value. But this is like we are evaluating the 8 with a function. This is an identity function, and the interpreter interprets it like he applies the identity function to a number 8, and the result of that is 8. So it's not the same thing, even though the output is the same. So let's try to build our 2d plus 3. Let's change it back to d. So d again and 8. Let's say if d is 8, it gives us 8. But we have a different, so the expression is not just d. We have 2d plus 3 when d is 8. Okay, let's do 2d. So d, let's build it. 2d. We can't write 2d. We have to write 2 times d, right? 2 times d, because 2d is 2 times d. It's just not written like that, right? 2 times d and then 8. So we basically have a double one, right? We have a double. This is a double function. So if we give it a 2 times d, and let's say we give it now a 16, we have 32. So now you see, this would be such a fun way to do math in school. Like, you know, kids have to now do actual 8 times 2, but why? Why is that so important? Like, that's like so 19th century, like, you know, we don't, yeah, what are the benefits? Like what's the point of knowing the 2 times 8? I guess you will learn it in time. Like, do we actually do some kind of a mental thing? No, we kind of remembered that 2 times 8 is 16. We know it. We had that array, the multiplication table, right? So now, okay, let's try it again. And now we have 2d plus 3. Okay, so we have 2 times d plus, so that was the mistake before. We just wrote 2d instead of a star. We have to write a star. So plus 3. So plus 3, and when d is 8. And d is 8. And that's 19. So that's a great look. That's 19. And I write 19. Check. Keep going. I will keep going. So evaluate 15 through, I don't know how you say this, 15 divided by k when k is 3. right? We can already see it. 15 divided by 3 is 5. But let's write it again as a lambda. So that's about k. K is the known. No, we are inputting. We have the value of k. K is 3, and we have to input it here. Yeah, I'm not sure what would be the best way to explain this to kids, like the best words to use. Like, okay, let's do k. Let's do k. And what do we have? 15 divided by k. So that's it. And we input 3. And that's 5.0. Now we're getting a floating point number. We shouldn't get that. Maybe if I use div. Yes, if I use div, like 15 divided by k, we get 5. Yeah, that's great. So that's 5. All right, 5. Check. Am I recording? I'm not even sure. I am recording. All right. So that's good work. Keep going. Next question. Evaluate n divided by 6 plus 2 when n is 12. Same thing. We do now it's the n, and n divided by 6 plus 2. And we don't have to put these things in parentheses because division has a higher precedence, or what's the word, than adding, right? So that's it. And outside we put 12 and we get 4, right? And that's 4. Check. Nice work. You got it. Onward. See how we answered this question. How did you answer it? Let's substitute 12 for n. Let's substitute 12 for n. Let's substitute 12 for n. So that's what we did. We substituted, the 12 goes inside of n, the lambda n. And then the argument n here gets a 12. 12 divided by 6 and plus 2. It's just that you can learn here how to, well, still this is still mental. You don't have tricks here. You just divide 12 by, look, it's not written. 12 divided by 6 is 2. 2 plus, so you are calculating instead of here. You kind of understand what's going on and you let the computer to compute, which would be much better. Yeah, next question. Evaluate c minus 2 when c is 7. Okay, so now we have c minus 2 when c is 7, and that's 5. You see, you don't have to think. Great work. You don't have, that sounds weird, but you don't have to think. Yes, you have to think, but it's a different way of thinking, I guess. Evaluate 6h. I think this is less stressful. I mean, this would be easier. This is a paradox, like in the sense that programming, in school they do programming, but they do Python and Scratch. And funny thing is, I think it would be nice if they do math along with programming, so they could really advance. I don't know, it would be really interesting, Evaluate 6h when h is 8. So again, we have an h, and now 6 times h when h is 8, and that's 48. 48, check. Keep going. 13 plus 6. Okay, now it's a bit different. Y, we have a y. Y, and what do we have? 13 plus 6. 6. This font can look, yeah, anyway. 13 plus 6. There, so 6 divided by y. Yeah, you can write by y, and y 6. So you get 14. Keep going. Evaluate j Now we have a j. So all these numbers, we have a j through 4, j divided by 4, and j is 12. So that's 3. Check. Great. Show summary. So I leveled up. You see, you should level up. Up next, now evaluating expression with 2 variables. This is interesting, right? Awesome.
Now let's think about expressions with more than one variable. So say I had the expression a plus a plus, I'll do a really simple one, a plus b. And I want to evaluate this expression when a is equal to 7 and b is equal to 2. And I encourage you to pause this and try this on your own. Well,
okay, we have a plus b and a 7 and b is 2. Let's try this on our own, as he says. So let's say we have an a lambda a, that will take a lambda b. I think will this work? And a plus b. And a is 7 and b is 2. Will this thing work? I am not sure. It does. A and b, a plus b. So we have a function that takes another function. I never know how to explain this. Let's ask ChatGPT, because this is, we should know words. We should know words. I'll log in. Log in, come on. So this thing, explain the evaluation with words. The expression a is a lambda function, also known as an anonymous function, that takes 2 arguments, a and b. So let's go to our GitHub. I didn't log in. Wait, I was trying out something. Let me pause and I'll just log in. I don't want to wait, stop. Where's the stop recording? Where's the pause recording? I don't have a pause recording. Stop recording. Studio mode. Can I pause? Oh, I cannot pause. Why I can't pause? Interesting. Start streaming scene. I don't know. Okay. Sign in. No stable joy. Wait, I can do this quickly. 35. Prove. Yeah, I'm in. Okay. So the Haskell Khan Academy, and I already started to early math, algebra, introduction to variables. So these are variables with equations with one variable, linear equations. So these 2 linear equations with variables on both sides. I think this comes later. All right, let's edit this file. Let's edit introduction to variables, linear on both sides. All right, let's do, what's the name of this? Evaluating expressions with 2 variables. Evaluating expressions with 2 variables. So what do we have here? So A and B, what did he say? involves substituting given values for each variable and simplifying the expression. By replacing variables with their corresponding values, we can easily compute the result of expressions, even for more complex examples with multiple terms and operations. Well, that's what he says. Well, let's copy this, all right. Created by Saul Khan. So, with multiple variables, with two variables. So now we have A and B. Okay, let's break it down. So the expression lambda A, let's break down the evaluation of the expression AB in step in words. Okay, let's break down step by step. Let's copy this too. Preview. Was this good? Yeah. All right, edit. So what's going on here? The expression is a lambda function, also known as an anonymous function that takes two arguments, A and B. Yes, so this is the description of the entire expression. This lambda function can be read as a function that takes an argument A and returns another function that takes an argument B and returns the result of A plus B. This is what I always, this lambda function can be read. Let's actually copy this entire thing. I like this. How does this look like even? All right. Maybe let's do this. A and B. No, it takes two arguments. A and B. Function can be read as a function that takes an argument A and returns another function that takes argument B and returns the result of A plus B. So this is what's confusing sometimes. Like the function, a function takes another function as an input that returns blah blah. But it's not. A function that takes an argument A and returns another function that takes an argument B. So it's a function that takes an argument A. Holy shit. Wait, it's a function. Oh, so the function itself is not this. It's like a box. It's a function that takes an argument A and returns another function that takes an argument B. I just realized now what I've been... This is silly. Another function that takes an argument B that takes an argument and returns the result of A plus B. So it's okay. So it's almost like, now again a trick, but it's like the function is this lambda here. But it's like this lambda denotes some kind of a box. Like some kind of a function, right? So these are values, and this is an operation, which is also a function. But yeah, that was confusing to me. How to explain this? What was confusing? Maybe someone else could feel like, because what's confusing is a function that takes an argument A and returns another function that takes an argument B. It's almost like you keep on looking at this side and you have the values here. Yeah. So it's almost like this box here. It's a function that takes an argument, what? This A, and returns a function, this thing, again, some kind of a box, that takes an argument B and returns what? Returns the result of A plus B. I guess the confusing thing is who returns the result of a plus b of these things. Maybe no one. Maybe this is the result. Like, does this function return the result? Because this function takes an a and this function takes a b and returns the result. Like, does this function do two things and this function does one thing? I guess that's one confusing thing. So this function takes an argument a, which is 7, and returns a function that takes an argument b, which is 2, and returns the result of a plus b. So yeah, so the confusing thing for me is, does the lambda b take an argument and then returns the result? It's like it does two things while the lambda a does only one thing, namely taking an argument. I understand where the confusion. Let's clarify this by focusing on the behavior of the lambda expression and the concept. Stop scrolling. Oh my God. And the concept of currying. Yes. Currying is a process in functional programming where a function with multiple arguments, as we have with a and b, is transformed into a series of functions that each take a single argument. Exactly. So we have here, she takes it, they don't have a gender. A function takes an a function takes a b, and returns. Who returns the result? So the expression involves currying. Let's break it down step by step, focusing on the roles of lambda a and lambda b. Outer lambda function lambda a. So the outer lambda function is lambda a, and the entire thing is written here. This can be read as a function that takes an argument a and returns another function, lambda b, a plus b. Well, you could look at it that way. So it's a function that takes an argument a and returns this whole thing. It's like there are all these steps that will be done later, but I don't care. So yeah, I guess I saw this somewhere, like a picture of some kind of a... Who said that? I read that somewhere. It was the functional programming course in Carnegie Mellon. I don't know. So anyway, it was saying like imperative programming is like you have a bunch of chefs who cook food, and each one cooks the food and no one has their own pans and pots and stuff. They all share, and you have all these effects like you cook the sauce and you have to go to the toilet. You come back and someone took your sauce and did something else, right? So you have all these effects. While in functional programming, each chef has their own desk with their own pans. Each of them have their own thing, which is, again, it's a complete thing. Here is like the function does one thing and returns, and so it's not concerned with what happens here. And that's why it says, and returns another function, blah, blah, blah. So it's not like this function does something to this. It just returns. Okay, application for the first argument. When we apply the value 7 to the outer lambda function, that's the 7 to the a, we substitute 7 for a in the expression, right? The result is a new lambda function. So this is now the result. So you could say there is always, this is the input and this is the result. So everything on the right side of this arrow is the result. Same as everything, like these are two functions and this is the result, a plus b. But who does the result? Maybe I'm too attached to this kind of thinking, who does what, you know? Maybe that's the problem sometimes. Like we're so used to, but who did this? And it's not important who did this, it's the process. Not sure. The result is a new lambda function. Okay. At this point, the lambda expression has not yet produced a final result. It has only transformed into another lambda function that takes one argument b. Okay, so this transforms into another function that takes an argument b, which is 2. Inner lambda function. So this is an outer and this is an inner lambda function. The inner lambda function is now b 7 plus b. This can be read as, oh, so this is now, so yeah, we're not seeing the next step in the multiplication. Yeah, I guess it would be nice to write that out. Wait, can you write out the evaluation steps so that I can see it like in real time, how the eval is progressing? No, I don't want it like that. Wait, I can give it an example. I know. Look, programming in Haskell. No, there's some programming in Haskell. Functional programming in Haskell. What's this? Accept the risk. Yes, everything for Haskell. Home pages, Brazil. Craft, no. Yeah, I have the book. It's just yeah. Wait, I have to find it. No, I can't stop. Oh, it's this. B, 7 plus B2. It's this. So the entire evaluation process is A plus B, 7, 2. B, 7 plus B, 2. And then 2 gets into B. 7 plus 2. So, oh, I see. We could do this like in school, right? We just had this. We had like, okay, A, we just did this. Okay, A is 7. We just did this. We just did this with the problems, right? Evaluate 2y when y is 6. So evaluate A plus B. Let's say we don't have a B, right? When A is 7. Evaluate A when A is 7. Is 7, right? Evaluate B when B is 2, right? That's 2. Evaluate A. Okay. Evaluate A. Evaluate A. A is 7 plus 2. 7 plus 2. 7 plus A plus. A plus 2. Yes. A plus 2 and A is 7. This is it. So evaluate A when A is A plus 2. Evaluate A plus 2 when A is 7. 9. Evaluate, or we could do the same thing with B. Evaluate B when B is B plus 7. Evaluate B plus 7 when B is 2. 9. So if we add this, and now we have A and B unknowns. Now we have A. So evaluate A when evaluate A plus B when A is 7 and B is 2. We get 9. 7 and 2. 9. Okay. So these two equations are equal. A plus 2 is 7, B plus 7 is 2. We both have 9s. Or we can write them like this. Yes. This is one way how to understand this. This is important. Did I write this here? Evaluate expression with one variable. So no, where's the two variables? Two variables. Okay. Okay. Yeah, I'm not sure what happened. Yeah, let's break down the evaluation. A plus 2 and B plus 7, A plus A times A is a function that takes an argument A, returns a function. Returns a function that takes an argument B and returns the result of A plus B. So the first thing is not that it just takes an argument. Okay, you see, it's fascinating. So it's not like the A just takes an argument A. It returns this entire function. That does what? It takes an argument B and returns the result of A plus B. What did he write here? Step relation words, outer, inner. The expression B applies the value 2 to the inner lambda function. When 2 is applied to B, it substitutes 2 for B a final evaluation. The expression 7 plus 2 is a simple arithmetic operation that values to 9. So, outer lambda function, A plus B takes 7 as the first argument, resulting in the inner lambda function B, 7 plus B. Now, the inner lambda function B, 7 plus B, takes 2 as the second argument, resulting in the final value 7 plus 2. The arithmetic operation 7 plus 2 evaluates 2g. So, okay, so which function does the actual 7 plus 2? The actual arithmetic operation, this scroll thing is really annoying. The actual arithmetic operation 7 plus 2 is performed by the inner lambda function B, 7 plus B. Oh, so it is. Step by step. A plus B, 7 plus 2. Application of the first argument. 7 is bound to A. In the expression A plus B, application of the second argument. The resulting inner lambda function is then applied to 2. This transforms into expression 7 plus 2. Here 2 is bound to B in the expression 7 plus B. The arithmetic is performed. Outer lambda function takes an argument and returns a new function. After applying 7 to A, it returns B, 7 plus B. The inner lambda function B, 7 plus B takes an argument B and returns the result of the 7 plus B. After applying 2 to B, it performs the arithmetic operation 7 plus 2. So to directly answer a question, the inner lambda function B, 7 plus B is the one that performs the actual 7 plus 2 operation. Yeah. Wow. It's kind of hard and not. So like someone could say, like, how can you teach this to kids? Well, I think this is interesting because it describes a flow of things, some kind of operation. Yeah, I don't know. I just think, I don't know. I know. I think this would be really interesting. All right. Yeah, I actually want to show this, and I want to tweet about this also. Carbon, what's this? Carbon SH. Not sure if that's the, no, it's not. Carbon SH, pretty code, whatever. Carbon SH. Carbon now SH. All right. So this was what? Evaluating expressions with two variables. Okay. Evaluating expressions with two variables, editor. This is nice to like hack anonymous Cascadia code. Let's do Cascadia code. This, and like this. All right. Fida code. Yeah. So evaluating expressions with two variables. B, A plus B. Yeah, tweet. I don't know, it's not really exporting. Carbon. Let's do here, downloads. Yeah. Yeah, this is it. I want to tweet this. Okay.
Wherever we see the A, we would just replace it with the 7. And wherever we see the B, we would replace it with the 2. So when A equals 7 and B equals 2, this expression will be 7 plus 2, which of course is equal to 9. So this expression would be equal to 9 in this circumstance. Let's do a slightly more complicated one. Let's say we have the expression x times y minus y plus x plus, actually let's make it plus 3x, or another way of saying it, plus 3 times x. So let's evaluate this when
x times y minus y plus 3 times x. So this should be the same, right? X wait. I want a different color. No, sumac night. Let's try sumac night. Sumac stone. Is this stone? Oh, there's also okay. My is it dark? Wings light. Blank. No, it's okay. I don't know. I'll just do this. Yeah. X, Y. So we have a variable. We have an argument. We have two variables. So that already means a lambda x and a lambda y, because the function, why is that true? So we only need two functions because we have two variables. Yes, each function takes a single argument. We have two variables. That means we need two functions. So we have lambda x will do something and output another function and return another function, lambda y. Now, and this will return what? The result of what? Of doing x times y. Now comes the operation itself. X times y minus y plus 3 times x. 3 times x. And that's it. Now, we need the value of x and y. We cannot solve this.
When x is equal to 3 and y is equal to 2. And once
so y is...
Again, I encourage you to pause this video.
Okay, we'll pause this video. So x is 3 and y is 2. So this should work. 13. Right? But what's the 13 itself? Like the 13... So we are now evaluating expressions. These are not equations. Yes, the equations somehow work differently. Evaluating expression with two variables. So that's 13. So, wow. xy minus y plus 3. So, wow. So now we have xy minus y plus 3x. xy minus y plus 3x. So this will be this. Now, can we break this to... so the x is a function. Like, let's substitute it with y. Let's substitute the y's. Like, let's turn it into a... We have two variables. Let's turn it into a function with one variable. No, that will be lambda x gives x plus x times, and y is what? What's y? Y is 2. X times 2 minus 2 plus 3 times x, right? And x is 3. So you see this? That's 13. We still get 13. And let's do it with y. Lambda y is x. X is what? X is 3. 3 times y minus 2 plus 3 times 3. And y is 2. So that's also 3. We could even compare this like the first one first and the second so it's the first equal to second. It's equivalent to second, yes. First var and second var, yeah. Well, let's copy this too, because it kind of brings things more into context. Yeah.
Try this on your own. Well, everywhere we see an x, let's replace it with a 3. Every place we see a y, let's replace it with a 2. So this is going to be equal to 3 times y, and y is 2 in this case. 3 times 2 minus 2 plus this 3 times x, but x is also now equal to 3. So what is this going to be equal to? Well, this is going to be equal to 3 times 2 is 6. This 3 times 3 is 9. So it simplifies to 6 minus 2, which is 4, plus 9, which is equal to 13. So in this case, it is equal to 13.
next? What's next? Evaluating expressions with two variables. We already evaluated expressions with one variable. Now it's time to do it with two variables. There's another video.
Now let's think about expressions with more than one variable. So say I had the expression a plus, I'll do a really simple one, a plus b. And I want to evaluate this expression when a.
Evaluating expressions with multiple variables. Let's go, ready to practice. All right, 3 plus jk let's post this, right? It's great. Like, why am I showing this to you? Because it's, you should update what you're doing with two variables. B. All right, learning, evaluating. Evaluate expressions, two variables. Evaluate expressions with two variables. Right. Ooh. Yeah. But now it's 3 plus jk plus k3 j. So again, okay, what do we have? We have a wait. I want Groovebox. I changed so much today. Wait. So 3 plus jk plus k on an exponent, k times k times k. That's k on the third. Yeah, when j and k. So we have j2 and k6. So let's start with j, right? Let's start with j. And let's start with k. And j is 2 and k is 6. So like j is 2 and k is 6. So it's like j plus k, right? And j is 2 and k is 6. That's 8. I think it's cool to build stuff like this. We do it like with program. Okay. But we don't have j plus k. We have 3 plus j times k. So we have, let's build it like this. So we have j times k, that's 12, right? But we have 3 plus. We have 3 plus. It's fun like this. We have 15, all right. And we have k times k times k. And what is this? Plus k, that's 21. Well, we have k times k times k. So that's 231. 231, check. Good work. All right. 2 and 6. Evaluate. So okay, let's will it copy? I don't know. Haskell. Oh no. Evaluate 3 plus jk plus evaluate 3 plus jk plus k. I don't know how to write this. jk evaluate 3 plus when j when j equals, yeah, this takes a while. I really want to just copy this, but 2 and k is 6. 2 and k is 6. Haskell. So we have this. Yeah. All right, next question. 8RRS. So this is the same thing. 8RRS. I guess I can stop now even with the recording. I think this is clear, but let's do this one. 8RRS. So again, we have an R and an S. I guess you can start with that, R and S. So we have a lambda R. It's some kind of a function that will output something and take an argument of S. And this will output the result, which will be 8 times R minus R times S. And that's it. And what's R is 6 and S is 5. R is 6 and S is 5. I guess the important thing is, like, look at this. The outer lambda takes this, you could almost say, inner argument, but like maybe this is, it depends how you look at it. Like, you see, this is inside, this is on the left side, the 6, and it goes into R, and the 5 goes into S. I guess that's important not to get confused about. 18. Let's try 18. Check. Great work. Oh, let's do more. F, G, and H. 3 variables. 3 variables. All right. So now we're going to have a big lambda. We have an F, G, and H. F, we have a G. We'll just write it shorter legs, and we have an H. F, G, and H. Right? Maybe we should add space here at least. Right? F, G, and H. And what's going to happen? F times F times F plus 11 times G minus 4 times H. That's it. And what? F is 3, G is 2, H is 7. Look, so 3 to 7. 3 to 7. 21. You see how simple is this? 21. Good work. Keep going. So let's, yeah, I cannot copy this. Well, we could just copy this. Why not? R, JK. What did we write here? JK. All right. Well, let's just write them here. We don't have, it's, I think it's clear from the, yeah, let's just copy this. All right, let's commit this. I want to commit. So multiple variables. We did this. Next question. 3 plus 11t minus 9u when t9 and u11. All right. So we have a t and a u. Lambda t, lambda u. And what's going to happen? 3 plus 11 times t minus 9u. Minus 9 times u. And the t is 9. And the u is 11. You see, now it's almost very straightforward. straightforward, as they would say. Straightforward. Check, keep going, show summary. Okay, I leveled up. Awesome. Next lesson. So writing basic expressions with variables, basic algebraic word variables. Write an expression to represent j minus 15. Not sure what's this. Let's see how long have I been recording. An hour. Perfect time to stop. Oh, this was really fun. All right. So yeah, bye-bye.